Welcome to aminacademy.com. In material science and engineering, let us do some example problem solving on hydrogen atom. Look at this example. Calculate the radius and frequency of an electron in Bohr's first orbit in hydrogen atom, given that epsilon 0 is given, mass of electron, charge of an electron, and h, Planck's constant is given. Now, here radius of nth orbit is given for hydrogen atom, epsilon 0 n square h square over pi m z square. By using this formula, we can find radius of nth orbit. Here first, now Rn equal, we can put first orbit R1, substitute n equal to 1, that is epsilon 0 8.854 into 10 power minus 12 1 squared, Planck's constant h equal 6.625 into 10 power minus 34 the square over pi 3.14, and mass of an electron is 9.1 into 10 power minus 31 kg, and z equal to 1. And E square, charge of an electron is 1.6 into 10 power minus 19 the square. By simplification, we'll get, by using scientific calculator, we get this one as 5.3 into 10 power minus 11 meter. Consider this as 5.3 0.53 into 10 power minus 10, which is equal 0.53 angstrom unit. 1 angstrom unit, you know that 10 power minus 10. Now next, orbital frequency. Orbital frequency formula, that is V equal mz square p power 4 over 4 pi epsilon 0 square n cube h cube equal 9.1 into 10 power minus 31 kg, and z is 1, that is 1 square. E is 1.6 charge upon electron is 10 power minus 19 whole power 4 over 4. Epsilon 0 is 8.854 into 10 power minus 12 the square, and n is 1, that is 1 cube, and h, Planck's constant, is 6.625 into 10 power minus 34 whole cube. Now by simplification we get this as 6.54 into 10 to the power of 15 hertz orbital frequency of an hydrogen atom, that is orbital frequency of an electron. Next question, show that the radius, show that energy released by an electron jumping from orbit 3 to orbit 1 and the energy emitted. Here orbit, higher orbit, lower orbit, that energy is emitted by an electron jumping from 2 to 1 or in the ratio. We have to electron emitted from orbit 3 to 1 and you have to find orbit 2 to 1 and this ratio must be 32:27. Yeah, the energy of an electron in the nth orbit of Bohr orbit, nth Bohr's orbit is given as En, energy in nth orbit is minus 13.6 z square over n square electron volt. Now by using 3 to 1 first. Now first E1, first orbit, E1 equal minus 13.6 into z square over n square is 1 electron volt. N equal to 2, that is second orbit, energy is minus 13.6 z square over 2 square electron volt. Then n equal to 3, that is energy 3 minus 13.6 z square over 3 square electron volt. Now energy emitted from jumping from orbit 3 to orbit 1. Energy emitted from jumping 3 to 1, that is E3 minus A1, H is equal minus 13.6 z square over 3 square minus of minus 13.6 z square over 2 square. So simplifying both, that is take out minus 13.6 z square 1 over 9 because 3 square minus 1 over this one, not true here, one equal minus 13.6 z square 1 over 9 minus 1 is minus 8 over 9. Now let it be 1. Now next is from orbit 2 to orbit 1, that is E2 minus E1 is equal minus 13.6 z square over 2 square minus of minus 13.6 z square over 1 square, which is equal, the common is minus 13.6 z square 1 by 4, because 2 square 1 by 1, which is equal minus 13.6 z square 1 by 4 minus 1 is minus 3 by 4. 3 by 4. That equation, it is equation 2. Now ratio I have to find, that is 1 over 2. The equation 1 over 2 is E3 minus E1 over E2 minus E1, which is equal 8 over 9, because the common terms cut. Then which is equal minus 8 over 9 over minus 8 over 9 over minus 3 over 4, which is minus will go 8 over 9 into 4 over minus 3, 4 over 3, which is equal, it becomes, ratio is 32 over 32, ratio 3 nines are 27. Next one, how many revolutions does an electron in the first Bohr orbit of hydrogen make per second? Determine the orbital frequency, that is determine the orbital frequency of an electron first Bohr orbit of in an hydrogen atom. That is how many revolutions. That's called orbital frequency. You can put it as orbital frequency. Orbital frequency. Now here the given n equal to 1 first Bohr orbit and z equal to 1 for hydrogen atom. Atomic number is 1 for now the orbital frequency. See formula, equal Vn equal m z squared e power 4 over 4 epsilon 0 square h cube n cube. We are applying the values, substituting the values of various, that is, we have, that means m is mass of electron, z is atomic number, E is charge, and epsilon 0 permeability or phase space, h is Planck's constant, n equal to orbital number. Then from this we can, because we have already previous problem, we have the values. This, from that we get, simply we get V1, that is first orbital frequency is 6.56 into 10 power 15 hertz. This much orbital frequency of an electron of hydrogen atom. So far we discussed about some solving problem on hydrogen atom. We have done. Please subscribe our YouTube channel.